Garlic might be famous for warding off vampires and ruining your breath before first dates, but underneath its pungent charm is a biochemistry powerhouse that deserves way more respect than it gets from your spice rack. At the heart of garlic's medicinal clout lies allicin, a sulfur-based compound that forms the moment you crush, chop, or chew fresh garlic. This molecular ninja doesn't just make your kitchen smell like a rustic Italian grandma's dream, it's a full-blown DNA bodyguard, operating under oxidative siege and environmental chaos. Here's the breakdown. When your cells are exposed to mutagens, think cigarette smoke, air pollution, heavy metals, radiation, or just your run-of-the-mill stress-induced ROS, reactive oxygen species, the very strands of your DNA can suffer breaks, mispairings, and chemical modifications. This isn't just theoretical drama. These kinds of injuries can lead to mutations, precancerous changes, and accelerated cellular aging. But that's where allicin steps in like the garlic-scented superhero it is. One of allicin's primary roles is as a direct scavenger of free radicals. It's highly reactive with thiol groups, chemical structures found on oxidized proteins and radicals, allowing it to neutralize oxidative agents before they shred your DNA, like a bad editor on a deadline. Essentially, it acts as a frontline interceptor, preventing damage before your repair enzymes even have to clock in. It's nature's own preemptive strike. But the story gets even better. Allicin doesn't just mop up the mess, it also calls in reinforcements. Studies have shown that allicin can upregulate DNA repair proteins such as OGG1, which corrects oxidative lesions on guanine bases, and P53, the famed tumor suppressor that coordinates damage response. This dual action, prevention plus repair, gives allicin the rare distinction of being both shield and fix-a-crew. Your cells don't just survive mutagenic stress better, they bounce back faster. Allicin also supports the activation of transcription factors like NRF2, the master regulator of the antioxidant defense system. Once triggered, NRF2 switches on genes that help detoxify harmful compounds, restore redox balance, and synthesize glutathione, your cell's top antioxidant. So, in a cascade effect, garlic doesn't just offer a quick biochemical band-aid, it rewires your internal safety protocols to handle stress better long-term. Talk about culinary resilience. What makes allicin especially cool is that it's highly transient. It doesn't linger long in the body, which means its effects are like well-timed bursts of molecular encouragement. That's why the regular consumption of raw or lightly cooked garlic matters. You're not trying to build up a stash of allicin. You're triggering short, sharp, beneficial biological alarms that reset your system's stress response each time. And let's not overlook its broader role in anti-aging and cancer prevention. By reducing DNA damage and maintaining repair integrity, allicin helps delay cellular senescence, preserve genomic fidelity, and reduce the kinds of mutations that can lead to cancerous transformation. It's like garlic tells your DNA, "You're not falling apart on my watch." Of course, there's a catch. Allicin is delicate. It forms only when garlic is crushed or chopped and begins to degrade within minutes when exposed to heat. So if you want to harness its DNA protective powers, raw is best, or at least wait 10 minutes after chopping before tossing it into a pan. Yes, your kitchen will smell like a medieval apothecary, but your mitochondria will be dancing. So next time you flavor your meal with garlic, know that you're doing more than adding depth to your pasta or roast. You're giving your cells a molecular toolkit to fend off mutagens, repair genetic bruises, and stand tall in the face of oxidative mayhem. Garlic isn't just seasoning, it's self-defense with a kick.